Hello there, welcome to lesson number 10 in our series on using FluidDesigner for 3D printing to create Objet. Today's lesson we're going to show you how you can use parametric equations to create a bowl. And so if you go to FluidDesigner, first thing we need to do is to go to Learning Projects and Objet. And we're doing lesson number 10. So if we just scroll down to object number 10, just drag and drop number 10 bowl onto the workspace. And so this is the object that we're going to recreate in today's lesson. And we're going to do this using parametric equations. And all the instructions as usual are in the help panel here. And so what we're going to do is to add a mesh, and it's a math function called an XYZ math surface. So if we go to add mesh, math function, XYZ math surface, and if I just open that panel up slightly, and if we just go to view and zoom to selected, you'll see that the default object that's created is in fact a shell shape, and that three-dimensional shell shape, and it looks like a shell, and it is a shell in fact, because there's no thickness to this object. If we tried to print it, it wouldn't work because there's no thickness. This object is created with the three equations, the three default equations that appear when you select this function, this XYZ function. So we need to change these three equations to the equations written here in the help panel. So if we delete the first one there, now if I just do Control V on my keyboard, I'd already got that equation, 10 times 8 plus 5 cos V cos U, as is written in the help window here. I already had that stored in the memory, so I've just pasted it in, and as you can see, that dramatically changes the shape now. It's no longer a shell. But we still need two more equations to change this into a bowl. So if we delete that equation there and we type in the second equation, and the second equation is not much different from the first one. It's 10 times bracket 8 plus 5 times cos V bracket sine U. So instead of cos U, it's sine U. And as you can see, that's now given us this circle shape. We still haven't got a bowl, but we've not changed the equation in the Z direction yet. We need to change it to what's written here, not the one that's currently in the box. So we need 10 times 5 times sine bracket V times cos bracket 2 times V close bracket. And as you can see, when we do that, we get our bowl. So I'll just shut that window down slightly because we're still working on this one over here, and I'll just move this across. So as you can see, there's it's not exactly the same, it's almost the same though, because there are still some other values that we can change. The U value we leave it as 0, the U min we leave as 0, the U max we leave as 6.28. Now the U steps, well, we want to change it down to 24, it's 32 at the moment. Well, if I change this right down to 1, you'll see the object completely disappears. And if we change it to 2, part of it appears again, and 3, oh now that's interesting, what we've got is a triangular shaped bowl. Not entirely different from the finished product in terms of, the external dimensions are the same and the height looks pretty much the same, but we've got a three-sided object. So the U steps must be the 1, 2, 3 sides. So let's try 4 and see what happens. Yeah, sure enough, there's 4 sides. So you could produce a bowl that looks that shape, or 5 sides. Now this is the beauty of parametric equations. You can play around producing all sorts of different shaped objects. Now we're going to stick at 24. So we've got 24 segments going around this way. Now if we look at the V's, we've got a V min of 0. V max, we want to change that to 6.28. Now 6.28 is actually 2 times pi. If you think of pi back in your days in school, pi r squared for the area of a circle. So this is actually 2 pi, which if you do remember, it's the circumference of a circle. So that's what that value is. Now V steps, well again, let's move this right down to 1. Well, the object disappears, look, and let's see what V steps might be. Well, it's actually the number of segments going around this way. The U steps were the segments going around that direction. The V steps are the number of segments around this direction. So the more we've got here, the more segments we've got going around the object. And again, you can see as we change this, the object changes quite dramatically. So we can come up with all sorts of different shapes. So V steps is 18. Now, one thing to note here also is that if we go back to the original three equations, these values here, 10, 8 and 5, 10, 8 and 5, 10, 8, 10, 5 and 2, if we change them, changing those values will change the object as well. So if, for example, if I change this 10 at the front, if I change it to say 8, you'll see that the object changes in shape. If I change it down to 6, it changes again. So what that's doing is that this is the x equation and this is the x direction. So as we reduce this value, this becomes thinner and thinner. Yeah, so we originally had this as 10, so I'll return it to 10. So if we've got 10 and 10 here, we get a circular object. Okay, so I'm not going to go through all of this, but in the help window, the 10, 8, 5 and 2, as you change them, they will affect the shape and size of your object. So the equations affect it, the numbers in the equations can be used to change it, these parameters can be changed as well. So there are lots and lots of ways in which you can change these shapes and hopefully come up with something interesting or that you find interesting that you might want to print. Okay, so what we want to do now is just confirm this shape. So we just go to Tools, Object Tools and convert it to a mesh. And this object down at the bottom now, I'm actually going to delete this. So I've highlighted it and I'm going to press X on the keyboard and delete it. So this is the one that we've created in today's lesson. So what we need to do is to save this now. So if we go to File and go to Save As, and just go up through the menu system, go to My Projects, Objet Dart, save it as lesson number 10, as a bowl, as a Blender file. Now we can't print Blender files, so what we need to do is to export it as a printable file format, and we use Wavefronts OBJ. And I'm just going to save that on the desktop. And then I'm going to go to NetFab. Oops, still left that one open, I shouldn't have done. If I go to Project and Open, and go to the desktop and open number 10 bowl, which is what we've just saved, you can see that I get this error message. And as you can see, I was using this a few minutes ago and forgot to close it. So we've got a warning triangle here, we've got an error message. Let's try running extras and repair part. Just move it across and click on update. Oh, that's interesting. When I did this a few minutes ago, I didn't have any border edge problems or holes. But anyway, let's just run automatic repair and execute them and apply the repair and remove the old part. Okay, so NetFab has done some changes here. It has repaired some bits around the outside, and interestingly, it didn't do this a minute ago when I was looking at this, it's actually filled it in at the center as well. Now that's something you do need to be wary of sometimes with NetFab. It might fill in a bit that you don't want filled in. So really we ought to go back to FluidDesigner and delete that. But more importantly than that, we still have got some issues here which I want to talk about, and that's these faces going around here that are all red. There is an issue with these. So first of all, I'm going to say go to Part, Export Part, and export it as a wavefront object to the desktop as repaired normally. But that's not actually repaired. Okay, so what we need to do is we need to go back to FluidDesigner and have a look at what's going on. Well, I can't show you in FluidDesigner directly what the problem is. What I need to do is I need to switch the menu system from FluidDesigner to Blender. So if we click on the plus icon up in the corner there and switch to the Blender menu, and what I now need to do is to go with the object highlighted. I'm going to press the Tab key to go into edit mode. And as you can see, in Blender there's a lot more information displayed. Now we do recommend that for beginners you do use FluidDesigner. There's a lot less to cope with than there is in Blender. But occasionally you do need to go over to Blender. Now what we need to look at is the mesh display and the faces. And what we need to click on is this little icon here, the normals. This is what the problem is. If I click on this icon here for the normals and then we zoom in or look around this object, what you should notice is there's some blue lines sticking out around here and on the inside. But notice they're not sticking out on these surfaces here. And these at the bottom. And these are the ones that were red. If I just go back to NetFab, these are the faces that are red. So there is something happening, something wrong with those faces. And what's actually happening is they're facing in the wrong direction. It's very important from the point of view of 3D printing that all the faces on a mesh face in the same direction. And these ones with the lines coming out of them are facing a different direction from these other ones. Now if I select that face there, what I need to do to fix this is to flip the face around. And we can do that by opening up this window here, the toolbox. And if you go to shading UV, it's not the only way of going to this command, but go to shading UV, we've got a command here that talks about normals and flipping the normal direction. So if I click that one, and then if I just rotate this screen slightly, what you should notice is that that face now has got a blue line sticking out of it. If I flip it again, notice the blue line disappears. I'll just zoom in even more. Here's the blue line, look. Here's it disappearing. So I'm flipping the face. Now to fix this problem with this mesh, we'd really need to flip the faces of all the faces that are the wrong direction. So we need to go round the whole object wherever there is no line coming out and flip them. Now clearly that's really awkward, it's tedious, there's a lot of them to do. There is, however, a better way of doing it. And the better way of doing it is, instead of in this instance using NetFab Basic, if you go onto the internet and if you Google NetFab Cloud, that will take you to this web page where you can upload, repair, and download 3D printable files. Now the NetFab Cloud is available free of charge. You just need to register, you just need a Microsoft account. But it's completely free of charge, and NetFab Cloud does some extra changes to the mesh that NetFab Basic doesn't do. Now you only have to do this when you come across this problem with flipped faces. Normally, most of the work you do, NetFab Basic is enough. So if you join NetFab Cloud, join this website and upload your file to that, it will automatically flip the faces around and correct your mesh. Also, I found if you actually upload a file like that directly to a company like Shapeways, because they use NetFab, the NetFab Cloud, NetFab Professional they use, their system will also flip the faces for you. So it's not really necessary, it's not really a good idea for you to start trying to flip these yourself, as I've just shown you. It's tedious and very easy to miss one. Use an automated system like NetFab Cloud to do it for you. Now one other point to note is that if you're interested in parametric equations, if you go to our website at fluiddesigner.co.uk and if you go to help and if you click on Z, you go down to the bottom of the help menu, you will see a link there to XYZ math functions at mathcurve.com. And mathcurve.com is a really interesting website. It's actually written in French. So if you just go www.mathcurve.com, you'll get a site that's in French. Whereas if you click on our link here on our help page, you'll go to Google Translate, and you will therefore be able to understand a lot of it. That's if your first language is English, like me. And on here are lots and lots of pages about curves, Bezier curve, for example, chains, cylinders, various other options. And if you click on some of these, and not all of them, but some of them, and I'll give you one example here. If you click on this one, this is a torus knot, and if you've done some of our bracelet or ring examples, you will have created torus knots. And what's interesting about torus knots is they are created using these 3 parametric equations. Now, it's not simply a case of typing these into FluidDesigner. Yeah, in FluidDesigner you have to use U's and V's, not T's and N's. U's and V's. So sometimes you do have to change these. But in mathcurve.com you will find parametric equations listed, and you will often find examples of what sort of curve they will create. So you can play around at mathcurve.com and try and locate some parametric equations and see if you can enter them in yourself. Okay, so that's it. That's the end of this lesson on creating a bowl using FluidDesigner for 3D printing. Thank you.